Good afternoon, everyone. Welcome all you joining the public presentation hosted by the MFL Occupational Health Center. Today's the topic is about the importance of the hearing conservation in the workplace. We are so pleased to have Cory C. He is the president of the Protec Hearing Inc. and the Hearing Innovators Inc. Cory has worked as an industrial audiometric for 22 years and custom hearing protection technician. Cory is the president and the owner of the Hearing Innovators Inc. since 2013, and also the president and owner of the Protec Hearing Inc. since December 1st, 2024. Aside from hearing screening and managing hearing conservation program in workplaces all over the country, his main areas of specialties are noise, survey, and custom ear mold. So we would like to acknowledge that we are gathered on Treaty 1 territory, and that the Manitoba is located on the territories of the Anishinaabe, Anishinaabe, Dakota Oyate, Nittany, Inuit, Nakatuwik nations, and on the national homelands of the Red River Métis Nation. We acknowledge that northern Manitoba includes territories of the Inuit. As we gather on Treaty 1 territory, we recognize Treaty 3 territory, in particular Salt Lake 40 First Nation, and the source of Winnipeg clean water, drinking water. We also acknowledge Treaty 5 territory, including Nelson River, which provides us with access to most of our electricity. The Occupational Health Center acknowledges the devastating, lasting, and ongoing impact of the settler colonialism on Indigenous people and a deep lack of action toward truth and reconciliation. The OHC has embarked on a process of learning about Indigenous people's history, culture, and our role as settler with our staff, the board, and the volunteers under the guidance of the knowledge keeper Clayton Sandy. We commit ourselves to active accountability, truth, justice, equity, and reconciliations. So for most of you already know that we are recording this session. This session will be posted on our website after that. We will have the Q&A right after Cory presentation. We will leave about 10 to 15 minutes for the Q&A. Please put your comment and question on the chat area. Now, please join me to welcome Cory.
All right. Thank you very much, Stephanie. And thank you for having me here today. Some of you may know me or may know one of the organizations working with here, and welcome you too. So what I'm hoping you will get out of the conversation today is something to take away on how to apply hearing conservation at home and in the workplace. I'll give you some kind of practical applications from some of the most complicated parts of our regulation. We're going to go through the basics of sound, how we hear and recognize noise as a hazard, and then, of course, how to mitigate that hazard through hearing protection and noise control measures. The presentation, or the PowerPoint presentation I'm using today, includes all the slides that I use for different conversations or different presentations that we have with different occupational groups. So you're going to see me flip through this in different orders. I don't necessarily use the slides in chronological order, but there's a lot of information on the slides. So if you get copies or this recording, that can be useful. So what we'll go through first is, let's talk about our ears, how we hear, so we can appreciate what we're trying to protect. Okay. So I'm just going to go down to a section here. One moment. So here on the screen, we have a cross-section of the ear. And so the outside ear, the ear canal, the eardrum, little ossicles, a train of, I'm not sure, can you guys see my mouse cursor on this screen on your end? Like if I'm
yes,
pointing?
we do.
Okay. So right here is the eardrum. It's a little, very thin membrane of skin, and it separates the inner ear from the outer ear. And this little tube here goes to the back of your throat. So when you fly in an airplane, for example, the pressure out here is different than the pressure in here, and you might feel popping sound, and that's air bubbles going up and down the back of the eustachian tube, the back of your throat. That's why when you fly, it's good to swallow so you can clear that pressure and not have any pain here. But sound comes in here and it vibrates this eardrum, and then attached to that are a chain of little tiny bones, the smallest bones in our body, called the ossicles. You might remember from high school biology, the incus, malleus, stapes. Um, and there's three of them, and what they do is vibrate a signal or vibration into the cochlea. And the cochlea is this little snail-like structure, and it's full of hair cells or stereocilia. And this is basically the whole where everything happens when it comes to how we hear. This is a blow up of inside the cochlea. These are the hair cells. This is a fluid-filled sac. So fluid will move back and forth with vibration to agitate these hair cells and give us a signal that we hear something. Is a basic way of saying it. So I'm just going to go down one more. Here is an electron microscope view of the cochlea on a cross section. So these are hair cells or hair fibers from the stereocilia, and they wave back and forth in this fluid. And it's coiled all the way down to the top. So this is the entrance right here. So sound comes in here, and it goes all the way down to the bottom, the very end. Now, we hear low and high frequencies. So low frequencies comes in, and they will penetrate all the way through to the end because low frequency sound has a very wide wavelength. So it has a lot of momentum behind it. And I'm just going to go back here. So here's a typical graph of a sound wave. So the bigger the sound wave, the lower the frequency. There's less waves within a certain set. So there's a lot of air, a lot of mass, a lot of momentum in low frequency energy. And low frequency energy can penetrate objects a lot easier than high frequency energy. When we're dealing with attenuating or lessening the amount of noise inside the ear, or if we're creating structures to isolate noise, the heavier and the denser the material, the better, because it's very easy to attenuate high frequency, but not so easy to attenuate low pitch. You can get this kind of you could kind of hear this when you're in traffic and say there's a car beside you that has a really loud stereo. What do you hear? The high pitch or the low pitch? You hear the bass. You feel the bass. It goes through everything, right? So when we go back to the cochlea now, so if this is fluid filled, it's a bit of a resistance. So low frequency energy will actually agitate more of the hair cells than high frequency energy of the same volume. So high frequency energy attenuates and doesn't necessarily get to stimulate all the way down to the end, or not in the same magnitude. So that's how we kind of interpret a low versus high frequency sound, is basically by what set of hair cells are agitated. And just the pure physics of sound and the way the cochlea is designed is it propagates through depending on how low or high or how much volume there is. So what happens here, you get this wear spot. And this particular cochlea is an example of noise-induced hearing loss. And as you can see, it's actually a physical damage and loss of hair cells, nerve cells, to hear those frequencies. And if all sound low and high frequency is coming into the cochlea, the first turn is right here before it goes up into the rest. So this is just a high traffic area because all sound, low and high, will go through this first part. And if you can imagine waves coming down here, crashing, creating a lot of turbulence, and then going to the rest of the cochlea, this is where you get that nerve damage. So that is physically the damage that's done from noise inside the ear. It's just microscopic. Now, the problem with this is a little bit insidious because you can't amplify sound for you to hear those frequencies if you don't have the nerves to begin with. And that is the biggest exacerbation of noise-induced hearing loss is the inability to get any of that hearing back. We can lose hearing because of infections, age, of course, but noise-induced hearing loss is a sharp, selective damage to the cochlea. And contrary to popular belief, it's not necessarily a reduction in hearing. It's a distortion of hearing would be a better description of it. And so that's what we're looking for. So how do we look for it? I'll show you the next graph here. We do hearing tests. So we test someone's hearing, and then every couple of years, a year to 2 years, depending on the regulation and the territory you're in, we test to see if you're needing more volume, essentially, at one frequency versus the other. So we're looking for this audiometric notch. And that means, at 4,000 or 6,000 hertz, we see the amount of volume going south relative to its neighboring frequencies. And that's basically a graphical representation of this loss here. It's, that's the simple thing that we're trying to do. We test these frequencies here, which are more in the conversational speech range. And this up here are really high frequencies, most involved in the t, sh sounds. Those p, sh. I don't know if the sound is that good on your end, but it's those P's, T's, S's, and often the types of frequencies in speech that clarify speech. So, for example, when you have someone who can't hear in this area, they'll still hear you say chair, but they might not be able to distinguish whether you said chair or stare because that's t. And what exacerbates this issue is in background noise. One of the things we use when we're listening to someone in front of us is those speech cues and those high frequency clarities to determine the difference between chair and stare, as my previous example. But also, it helps us distinguish that from background noise because someone else further away saying the same word, those high frequencies are lost sooner. So their voices will be a little more muffled than the person in front of you. But when you have this type of hearing loss, they all become the same. So you could watch TV and have a quiet fridge start up, and that'll be more distracting than anything because you can't hear the speech on the television. Or if you're, of course, at a social event, a wedding social or a bar, you'll have difficulty hearing people talk because it all just mumbles into itself. When we test people in industry, we get some people as brazen saying, well, I'll just get a hearing aid to replace my hearing that I lose. I'm not worried about wearing hearing protection. Problem with that is that once you lose these hair cells, I can turn the volume up on a hearing aid in that frequency range. And if you don't have the nerves to pick it up, how are you going to hear it? So, these individuals will have great difficulty with assistive listening devices and hearing aids. Far too many of them, get new hearing aids and then leave them in the top drawer. We might have aunts or uncles or people who have hearing loss who don't wear their hearing aids. I'm sure everyone has an example or knows of that, and it's more common than it should be. Of course, part of that is learning to hear those frequencies again, but far too often it's the screeching distortion and the difficulty of trying to program the hearing aid just to this area. So it's sad. Hearing loss because of noise or any type of hearing loss can be socially isolating. There are now studies that it could exacerbate or lead to or increase your probability for dementia and Alzheimer's, simply because when you don't use parts of the brain in the auditory range or from the auditory nerve, there's parts of the brains that are used to processing the auditory signals. Loss of this stimulus to the brain creates degradation. It's like muscles, use it or lose it. So that's why it's important, if you have hearing loss, you get it checked out. If you need assistive listening devices or hearing aids, you get those. Like glasses or cataract surgery, all these senses in our body contribute to issues with our brains as we get older. So keeping all the senses clear and hearing is the most sensitive part of our sensory perception because it involves the most information more than vision. So basically, what I'm trying to do is sell to you or promote to you why we want to be very careful with our hearing. And now I'm going to talk about how noise destroys it. So if we know what the damage, if we know what happens to our hearing because of noise, then in our workplaces and in our environments, a good tool would be to measure that noise, know what the risk is, and then we can apply the regulation, which is really a bare minimum to protect your hearing, at the very least. But I'm going to describe some variations from the regulation where you should to mitigate all loss of hearing related to noise. And we have a tool in the CSA guidelines. I have it up there, Z10756-18, which actually specifically lays out on how to do an occupational noise hazard assessment in a workplace. So this is related to workplaces, though you could take some of this also into your own home environment. We need to put a single number to the risk for noise to make it easy to apply to hearing protection and noise control measures. And so you're going to hear me talk a lot in this next little section about a noise measurement called LEX. So I'm just going to go back up here. So again, when we're talking about measuring noise, we're talking about looking at all the frequencies coming out of a machine or an environment, um, and looking at the cumulative wave height, which is the intensity. So noise of any frequency, it really just comes down to volume. It's almost independent of the frequency. I did talk about the frequencies on how our ears receive and recognize low frequency versus high frequency. But remember, all frequencies go through that first part of the cochlea to cause damage. So we need to look at that single number, which encompasses all the frequencies coming at you at once and gives us a measurement for the wave height or volume. We just need to measure the volume. And so what we look at is the LEQ first. Those who work in occupational health and safety, or maybe administer hearing conservation programs in their workplace might be familiar with some of these terms. LEQ used to be what we use to describe time-weighted averages, but now we convert everything to what's called a LEX. And I'm not going to get into on how to do the math, but this is going to be a good way to kind of just wrap your brain around the concept. So an LEQ is simply a time-weighted noise sample. An LEQ could be done for an hour. It's usually done with a meter that's sitting on your shoulder or clipped to your collar or front pocket, etc. And it's with your person. The idea is we want to measure how much noise is coming to your ears from your perspective. Past noise exposure, past noise exposure assessments, we've been doing them for a while. There's been a change from the typical handheld meter going around and pointing at the equipment, or standing in this room seeing how loud it is. That is almost useless. I'll say that again, it's useless. To stand around and point equipment or point a noise meter at equipment, whether it's a noise meter you got from Radio Shack or an actual Type 2 occupational device, a sound level meter, to just get instant readings does not actually help you. Really, it gives you a guide. There's some direction you can get from using a meter, but you cannot answer the questions as to whether the noise is actually a risk. As an example, I can take a noise meter and point it to this photocopier behind me when it's running, and then get 95 decibels on an A-weighted scale from it. I sit right beside this photocopier. Does that mean I am going to have noise-induced hearing loss? No, because the way noise propagates out, it dissipates with distance. As you can see in this little paragraph or this little illustration, you get a source of noise and the intensity or the height of that wavelength as it spreads out, there's only so much energy. So the energy spreads out, becomes less of an issue. Like an ocean wave or dropping a pebble in a pond. The wave at the rate where the pebble comes in or the source of the energy is really high, and then it just comes out to a very flat ripple. Well, same thing with noise, just on a three-dimensional scale with air pressure. So when we're trying to measure noise, we need to know how much of that pebble, that wave that's come or from the source of noise, how much is actually coming to our ear. We have I don't know if you guys can see me necessarily, but when I've done a presentation before where we kind of showed trying to illustrate how fast sound degrades or the volume degrades from source. Um, we use calibrators for our noise equipment. So we'll stick the mic down inside a little calibrator, turn it on, and that calibrator will produce 110 decibels. And I love turning that on to show people it's like, okay, I'm going to blast you with 110 decibels. Well, it's 110 decibels here, right here, but not out there. It's barely audible out there. So, this just really shows you that our perception of sound is inaccurate. You really need this equipment. You need to go through a proper procedure to determine your risk. So we put a dosimeter on someone, and the dosimeter will measure noise and weight it over time. So the more time at a higher noise, the greater the risk. So it's both intensity and duration. You need those two. Of course, the higher the noise, the less time in it before it becomes a loss of hearing or risk for loss of hearing. And we use the 80 over 8, 80 decibels over 8 hours. That is our limit. Now, in Manitoba, we use 85 as a limit for mandatory hearing protection, mandatory hearing testing, but you can still get hearing loss being exposed to 82 decibels over 8 hours. So anything 80 decibels for greater than for 8 hours or greater is a risk for noise-induced hearing loss. So there's a couple things at play. We have the time that we spend in noise, which is relative, and the noise volume. We have work shifts that are 12 hours, and we have work shifts that are 8 hours. We have work sites that are variable. Sometimes machines on and then it's off, and it's on and then it's off. While it's on, it might be 110 decibels. While it's off, the shop could be that you're working in maybe 60 decibels. So this is where that handheld meter may really becomes ineffective. All too often, we go and we point a meter at a machine, as I said earlier, and determine, well, when that machine's on, it's 98 decibels in here. So now we're going to use that as we're going to have to do annual hearing testing here. We're going to have to do provide mandatory hearing protection. Maybe we'll wear plugs and muffs, and just so we make sure our workers are protected. But to do it through the CSA noise survey, if you did a dosimetry, you might find that it's 77 decibels on the dosimeter because maybe that machine's only on for 2 hours of the day. So it is really relative to the cumulative effect of all the noise sources and all little durations into one sample, and that's this LEX. So the LEQ is just a description of time weighted average over different periods of time. So you might put a meter on for 3 hours or 4 hours or 5 hours. That'd be your LEQ4. And then we look at the LEX and we convert everything or extrapolate into what's, you might see a TWA, time weighted average projected, as an old term that I've seen some reports, but now CSA, the regulations, we all talk about this LEX. And an LEQ measurement done over 8 hours is basically equal to LEX. It's the same kind of a synonymous term if the times are the same. So if you do an LEQ over 12 hours to convert it to a LEX, you actually have to add noise to it. So if I'm listening to 80 decibels for 12 hours, and I compare it to someone who's listening to 80 decibels over 8 hours, my noise exposure is greater because I have a longer shift. And that's really where this LEX helps us, because no matter what length the shift is, whether they're working in it for 4 hours, 12 hours, 8 hours, when you do this noise survey and you pare everything down, you can compare all the LEXs together to find out where you need to put hearing protection on and what kind of parts of the regulation you have to apply. Because it does encompass all those variables into one number. It's a great tool. And then once you know your LEX and you've converted it based on the shift length, we can go through and apply what the risk might be. And we can figure out what type of hearing protection or noise control measures we need. And I'm going to go through that just a second here. Oh, that's digital. So the first thing people think of to protect our hearing is hearing protection. And there's a good way to do it. It's obviously often the only practical form of engineering or reducing the noises to protect your ears. And what does hearing protection do? Well, it reduces the noise going down into your ear. And if you reduce the noise, you can increase the amount of time you are in that noise. And if you decrease the noise down below 80 inside your ear, well, you can be there all day and should not, um, through all the studies that have been done, will not have noise-induced hearing loss. And there's all kinds of different types. And we're going to talk about how we measure this. But before I get into that, we should talk about engineering noise out of the workplace, because essentially the whole idea is to eliminate the risk altogether. When you're in industry, however, um, factory production makes noise. Printers, metal presses, brakes, grinding, welding, all these things create noise. Now, it's often difficult or impossible to eliminate the noise. But there's, things like maintenance on equipment, saws, anything that's unnecessarily making noise, squeaky wheels, for example, belts that are squealing, saws that aren't sharp. Um, and if you have a process in your environment and it's something that's a machine or something that creates a lot of noise, and it's affecting the noise of everyone else working in, say, a shop or a warehouse, an effective way to do it would be to isolate it, put walls up around it. It doesn't have to be perfect isolation, but if we've brought that noise down below 80 on average for the workers around there, then it frees them up not to have to wear hearing protection all the time. And then there's administrative noise controls. This is where you have a process. And when I think of administrative noise controls, I think of the aerospace industry doing testing on jet engines, for example. They have them isolated in a room. So we have engineering controls to take them out of that, and we might limit how much time they are exposed to that. So that's another way. And this is both acting on those two factors of noise-induced hearing loss risk, your intensity and your duration. So administrative noise controls is controlling your duration, your time exposed to it. You might have a process that's isolated, but you might cycle workers through it so that they're only exposed to it for a couple hours at a time, so their overall time weighted average is under or more manageable with earplugs. So after we've done all that, we are left with getting the most out of our earplugs. So how do we do that? So there are the classic noise reduction rating, which is your NRR, and then Europe uses an SNR. Essentially, the difference between them is how they're measured, but they both come out to give you an idea of how much hearing protection you're going to get. And without knowing the LEX, these numbers are useless. They really are. You need to know what your time weighted average is because that's how these have been designed. And I have a little description here. There is less of a D rating for SNR versus NRR. And that's because how they establish SNR is more of a real world attenuation. If you can imagine, to find out how much an earplug reduces a noise in the ear, you actually have to put them in and measure it, right? So to establish noise reduction ratings, you have to go through studies of groups of people putting hearing protection in. And there's a difference between these two, and one is where they've actually measured real world attenuation. They have gone into the area and had the individuals put the earplugs in themselves and then tested them after that. Where noise reduction or the NRR rating has a lot of derating you have to do after the fact. It's because there's disagreement on how the NRR is achieved, which is usually a technician putting the earplug in the ear. So there's a little more interference. So there's arguments there. If you talk to workplace safety and health, they'll give you some typical derating calculations to use for hearing protection. Here's an example. So we have an 8-hour TWA, which is your LEX, because it's 8 hours, time weighted average, LEX, of 93. We have an earplug or foam plug that shows it has 29 decibels of noise reduction. So we subtract 7, we get 22 decibels, we divide that by 2, and we get an 11 decibel noise reduction. So then you subtract that 11 away from the 93 to see if you're below 82, to see if you're below 80. Regulation wants you to make sure it's below 85. I will always say below 80 because that just eliminates the risk all entirely. So as you can see, you've got a foam plug that goes completely in the ear, and we're only getting 11 decibels of noise reduction out of it because we were applying this reduction rating to the NRR. Because all we're trying to do with an earplug is block the air going into your ears. So this derating is trying to establish some sort of standard to account for all the different shapes of ears and all the different ways people may put in this particular ear protector. And that's the foam plug. So if anyone's ever used one of these foam plugs, you have to roll it up, pull your ear out and up, put it in, hold it, wait for it to expand. And then you have rubber plugs, which you basically do the same thing, but you just push it into your ear until you get an acoustic seal. Whatever you're using, they all work great. And I would argue that they work better than whatever you derate them by in most cases. But even imagine if someone had a really big ear and the earplugs, only covering it can expand all at once, but it's not going to actually create this acoustic seal, touch all the portions of the ear. So how do you yourself know if you're getting enough hearing protection when you put these ear protectors in? You can follow the directions on the box, but how do you know if you're getting enough? If you're getting that acoustic seal, you're getting that air trap that we're looking for. Well, we've got a simple, it can be measured. There are fit testing services out there. And this is what I call the fit test hand rule of fit testing. So go out to put an earplug in your ear. And I challenge everyone to try this themselves. Maybe they've worn hearing protection for years, but this would be a good test to see if you've actually been wearing it properly. Put it in according to the manufacturer's instructions as deep as you can. And of course, put anything in your ears is going to sound quieter, but are you getting that acoustic seal? What a good way to check is to go out into noise, cup your hands over your ears. You can also use earmuffs. Cup your hands over your ears, pull your hands away. If you hear a difference doing that, it's better to do this lots of background noise so you can really tell through us. But if you hear a difference between your hands away and your hands on, that means your hands are hearing protection and these aren't. As simple as that. So you gotta readjust that earplugs until you get very little difference when you do that. And then you're good. And we've compared this to fit test studies, and it is an excellent way to tell if you're wearing your earplugs properly. Because you might have small ears, you might have an ear shape where the earplug's only half in the ear, according to the picture, right? But it still actually provides its acoustic seal. And here's an example of perfect use of a foam plug. You can barely see it. It's all the way down inside the ear canal, just a little bit sticking out. Some people get it in further, and some people only put it in halfway. But no matter what way you put it in, if it still passes this test, it should be okay. So these types of foam plugs or in-ear plugs are only as good as how much they're touching the inside of the ear. The next type of hearing protection we have, of course, are muffs. Here's a set of muffs here. I think I've got a picture back here. I told you I'm going to make you dizzy going back and forth through all these slides. Right here. So here's some examples of the muffs down here. They'll have different ratings. They're pretty high. We do derate muffs, though only by 25% as a rule of thumb. And I would argue, by the way, just back to the foam plugs. If you are getting that acoustic seal that I was talking about, you probably only have to take off 7 decibels of noise reduction rather than going through the full NRR. So they require some training with employees, and not to peddle our services, it's something we do. Okay, muffs. When you look at muffs, the muffs are only as good as this cushion here. If that's cracked or compressed or not good shape or ripped or whatever, that means you have to replace this the cushions on your muffs. Far too often when people come into the trailer when we're on-site testing, we notice these things are just compressed, and they like them because they're comfortable. They can still talk to people on the plant. And I always laugh. I'm like, well, if you can hear things really easily, it probably means they're not working. And a good way to test if these are working is, put them on your head, press on them, and let them go. And if you hear a big difference, that means those muffs aren't sealing properly. And things, that will interfere with this, of course, glasses, other safety gear. Um, so you really have to choose hearing protection based on the application. That's why even in the regulations, employers should provide a variety of hearing protection, is because not all ears are equal. Um, what we do, of course, the other option is custom molded earplugs. That's something that's individual. You take an ear impression, we take it back to our lab, scan it, create a cast, 3D print out a cast, fill it full of silicone, and we make these lovely little earplugs. And the great thing about this is that it fits just your ear. So we know we got an acoustic seal that's pretty reliable. Plus, it's really fixed. You got a helix lock. It goes back down the second bend. But then you can be cute with acoustic filtering for different applications. And of course, it's reusable. We're disposable foam plugs. You always want to protect the environment and limit what's going in the landfill. These will last you 3 to 5 years, where foam plugs, you can go through a lot of foam plugs in that time in industry. We have noticed a lot of heavy industry or loud industry gravitate to custom plugs more now in the last 2 or 3 years than they ever have, which we're happy to see. And by the way, just because I talk about the greatness of custom earplugs doesn't mean these don't give you the same amount of hearing protection. If you wear these properly, whether we are closing off the ear with a piece of plastic and cotton, or a foam plug, or actual custom mold, we're achieving the same goal. Custom earplug is not going to give you more hearing protection than a foam plug will. It's just the application of it. Once you block the ear, you got it. So I'm just going to review the regulations here. So in Manitoba, we'll talk about Manitoba only here. Um, we have criteria 80 and 85 decibels. Remember, that's that time weighted average. We have to ensure workplaces, we have to measure the noise, establish it. If there's a change in the environment or new equipment introduced, you should measure the noise again. Provide hearing protection as an option. It's not mandatory at this point under our current regulation. And educate people on the hazard of noise and how to use hearing protection. And um, constantly have a kind of a continuous improvement there. And can we take noise out? Are we giving the right hearing protection? If it's over 85, then the full gamut of the hearing conservation regulation gets applied. You have to seriously look at engineered noise controls if you got time weighted average in your operations above 85. And that's what I was talking to earlier about isolating a piece of equipment in a room, or looking at the time exposed to different types of processes in your environment. At least look at it. Your obligation is to engineer the noise out of your operations, but it's also that caveat in the regulations if reasonably practical, right? So if it's not, then you go to your secondary control, which is earplugs. You'll provide warning signs indicating that any person, workplace, or area are exposed to harmful noise. You have to do audiometric testing. And what audiometric testing does is test or surveil your control measures, whether it be noise, administrative, engineering, noise controls, or hearing protection use. Hearing testing is the best way to determine if these control measures are working, because it just looks at, is it causing the damage we're trying to prevent? And audiometric screening has evolved over the last 30 years to really narrow down to a pattern and a protocol that tests explicitly for this. And the screening that you have in workplaces is not like the testing you do at an audiological clinic for full assessments or other medical reasons. This is really just a pared down, efficient 7 frequencies or so to look at that change in one frequency versus its neighbors. And it's just a pattern. It's a little bit of math that we use. That we test every year, or at least every 2 years. Current regulation is every 2 years, by the way. And I would say most of our clients still do testing annually, because we have that ability to see these changes in real time before it becomes communicatively significant and often before it becomes permanent. I'm going to go back to this audiogram. So, for example, a hearing loss like this, it could take, from here to here, it could be about, depending on the amount of noise they're exposed to, it could be 5 years or 15 years. But notice how the conversational speech range is almost untouched in both of these scenarios here, from the right to left ear. So you do not have the ability, easily anyways, to really tell if you're losing your hearing because of noise. This screening that's done through testing programs in workplaces uh, will notice these things before it becomes an issue. And that's the whole idea. It's early warning detection. And then what do you do with that information when someone has lost, measured a measurable loss of hearing from one year to the next? Well, you review with an audiologist to determine what the cause of loss is, making sure that it is noise, not some other factor, of course. But once you determine that it's a noise-induced hearing loss, then you go back to this regulation and you go back to the beginning. Look at the noise volume in that person's individual work area. Um, Look at the noise control measures and often look at hearing protection use. Are they wearing it consistently? Have they been um, informed how to use or taught how to use hearing protection? Have they been taught about the risks of noise-induced hearing loss? Are you documenting all this? Because if nothing else, workplace safety and health will ask for those exact things. Documenting hearing protection use, consistency, training. It's all part of that onboarding new employees in most workplaces now. And it's good to see. And then if you have a hearing conservation program, whether you're doing the testing yourself internally or hiring a service like us, that's the big part of our job is at that point of audiometric testing is reviewing their hearing protection and asking them questions about their use of hearing protection. And of course, even noisy hobbies or things outside of work. It's all in an effort to see where the cracks are in your program and that hearing surveillance. So that pretty much sums this talk up. It's pretty simple. Plug your ears. Don't expose yourself to too much noise, and this is all a non-issue. Any questions?
Thank you, Cory. So really, really informative presentation. Give it to the audience here. So I just put the questions on the chat, asking folks to submit the comments and questions.
I see a question now. Do I just talk to answer the question?
Yeah. Oh, where can we get this matter? What is that?
A dosimeter. Yeah, a dosimeter. Occupational health and safety supply stores like I know Levitt Safety, Eklund's Granger. You can get them online. They have to be a Type 2 level meter. And I would recommend getting some training on how to use them. They're not necessarily user friendly. This is often used by a technician, with our background, or industrial hygienist might use them, but doesn't mean you can't. You can also, I believe the province used to, or may still have meters that they lend out. Some of the safety associations, Safety Service in Manitoba, I'm not sure if they have meters they lend out. But whatever you do, know how to use it. The other side of it is now with the new regulation, the CSA standard, it's really important that if you're going to use your measurements for occupational health and safety, your whole study has to follow that standard. So often it's easier to get someone else to do it, or if you work in an organization where you have the time and the resources to learn how to use the machine and then know how to prepare those surveys, or at least get someone else to vet them. Okay. Will the presentation be shared? Yeah. How useful is the Decibel app on a phone? So iPhones, in particular, measuring noise, if you set it to an A-weighted scale, slow response, they're very good. They're very good way of determining how loud your environment is at that moment. Remember that they're no better than any other type of handheld. You can't use it in a regulatory argument, of course, but it would tell you at least where If you see a sustained level that's above 80, that you want to do a dosimetry assessment there. It would be able to help you where you want to do a noise survey. So that in that regard, of course, just for home use, and remember, it's the machine will measure and give you numbers all over the place. It's where it's kind of staying or that range, wherever you are. That's what you want to pay attention to. Kind of ignore the peaks. Look at the range. Look at the averaging out. How much is a good dosimeter? They're a few thousand, up, $2,000 to $6,000. Then you need a calibrator and the software. So they're a bit of an investment. Usually industry or consulting services or hygienists own and operate these things, or you have to rent them. Live at Safety at one point used to rent them out. They're about $200 a day to rent them. How useful is the app? What's the average cost of custom earplugs? Custom hearing protection is about $150. If you're just individual coming down to the clinic to get a full block basic pair of custom hearing protection, it's $150. We implement them in workplaces at great numbers. Of course, we negotiate much lower than that for group orders. And then there's other things that increase the cost, like you're putting acoustic filtering, electronics, or comm units for radio communication, etc. What use are spot measurements? Oh, the use for a spot measurement is that instantaneous to measure a peak or the loudness of a particular process. It can be used for designing engineer controls, so you can find out what kind of or actually that's octoband analysis. Primarily in our industry, I'll use my spot meter to determine where I need to do dosimetry. Literally, I'm looking for, oh, the meter doesn't seem to be going less than 80 here. Let's make sure we get some meters on workers who work with this particular piece of equipment. It's just a reference. It gives you an idea of where to go for dosimetry. But workplace safety and health, you can hand them all the well-done spot metering surveys you've ever done, and they will throw it right back in your face. They do not accept it anymore. It has to be time-weighted Lex samples done by a dosimeter, a worn dosimeter. Peak noise can definitely cause hearing loss if it's high enough. Gunshot, for example. One of the questions we ask when we're doing oto history for an audiogram is, do you hunt or shoot? Do you use firearms? That's a situation where you get an instant acoustic trauma, meaning the duration and the intensity. The intensity is so high, there's fractions of a second for duration to cause permanent, real measurable damage in one instant. So yes, definitely. Harsh percussion sounds from an explosion could do even damage to the ossicles and the eardrum, not alone on top of your cochlear nerve damage. So yes. What about noise canceling ear protection? Yeah, they work. There's lots on the market. Just be careful that whatever you're buying is an actual regulatory hearing protection device. And how do you know that? If it shows data or has a published SNR or NRR rating, single noise reduction rating or noise reduction rating. So the US and Canada, we use NRR, though I can tell you the international standard will be SNR in the future, and regulatory bodies are already looking at that. Are music venues required to provide hearing protection for patrons? Well, they're not employed, they're visiting. They could, I guess, that falls into a gray area, like it's a risk to the patrons. Of course, you'd have to quantify that risk. How long does the average patron stay there? Do you put a dosimeter on them? Do you pretend you're a patron? I know I've been to a social and wore my hearing protection. It happens. So it can cause hearing loss if that person goes to that loud bar or wherever it is all the time. It's the same as a worker. But the legalities of it, I think you're only liable to provide hearing protection to the people you employ, because the other people coming in on their own choice. This is probably above my qualifications as far as legalese go. Do you use AI being integrated into noise reduction and dramatically change the spectrum? Artificial intelligence, is that what you're talking about?
I believe so. Yeah.
Maybe I don't understand the
You
question.
see
I
AI
know that our I know that our CAD software, when we're designing ear molds, there's artificial intelligence that determines acoustic mass and where to trim the depth of the ear canal, like, and how big to make our chambers for acoustic mass. Um, and also um, the actual design of the template. So we use AI there, but that's in the digital processing side of audio prosthesis. But um, I don't think I'm answering your question though. I wonder if you could say it in a different way. Oh, the reliability of decimeter apps on cell phones. They are relatively good. We've done side by sides with both some of the Android apps and iPhone apps. They can be a good way to start to see where or if you need hearing conservation in your workplace. Of course, the end all answer again, I'll always say, is doing a decimeter test.
This is a question about the engineering control. Engineering
I'll do
controls,
that. Oh,
yeah.
engineering controls like insulating machinery, how effective can this be? Uh, very effective if you know what materials to use. We've consulted in aerospace and in the printing industry too on materials. And what we usually do is we do an octoband assessment, and that's very important because we want to see what frequencies the machine is loudest at, and then choose a physical substance to put as an insulator in the walls. So it can be very effective because if you think about it, say your machine puts out an average Lex sample of 90 decibels. We're not trying to get rid of 100% of that noise. If we wall it up and we bring down, 10, 20%, that might get us below the threshold. Okay. So you can sometimes just do this with wood framing and thick insulation. I think I answered
I think that's
everything.
all for the question we have on the chat. We want to give you another minute. Have any more question and comment?
Noise as a weapon? I don't know what you're asking. Acoustic trauma to an individual for as a weapon? I guess it can be. Anything can be used as a weapon, right? If it's directed right.
Yeah. Yep. I think that's all for today. On behalf of the Occupational Health Center, thanks again, Cory, for that great presentation. Your knowledge and expertise on that area have shared to us. We really appreciate it. And thank you all the participants, asking very great questions here on the chat. Yeah, appreciate that. And also your comment. So that presentation has been recorded. Is it okay we could share the PDF version of your slide to the folks? Some people email me, they missed your session, they cannot make it for today. Is
The
it okay?
PDF is free to share. The PDF I gave you is
Awesome.
free to share. Yeah, there's
That's
no
great.
proprietary information in there.
That's great. Thank you. Okay, have yourself a great afternoon all. Everyone, then see you next time. Bye.
Everyone keep their shovels out.
Yes. Okay, bye-bye.
Bye.